Good morning friends, this is Imran Khan and you are watching my channel for NEET-Physics. Today onwards we will be starting the previous year's questions from NEET or CBSE PMT. Okay, we will do all the questions which came in the exam NEET and PMT. Okay, let's begin today's class. First question, this chapter we are starting from units and measurement, chapter number 1 or second chapter we can say from the NCERT, that is units and measurement, and we will do first all questions which came from chapter number 2, units and measurement. Okay, we'll do this series for preparing 2023 NEET examination. Okay, so let's begin. The first question, which of the following has dimensions of pressure? Which of the following has dimensions of pressure? Along with the question practice, I will teach you the concepts also. Okay, so don't worry about that. And this question was asked in CBSE PMT 1990 and 1994. Okay, so this is very simple question. Pressure, you should know the formula of pressure. Okay, what is formula for pressure? Formula for pressure is force per unit area. Force per unit area. And what is force? Force is mass into acceleration. Mass into acceleration. Therefore, the dimensions of pressure will be equal to dimensions of mass into dimensions of acceleration upon dimensions of area. Dimensions of mass is m and acceleration Lt power minus 2. Then dimensions of area is L square. So what you will get? The dimensions of pressure is m L power minus 1, m L power minus 1, T power minus 2. So which option is correct? Option second. Okay, ml minus 1, T power minus 2 is correct. So option B is correct. Okay, these in the NEET examination they will ask only multiple choice questions. Okay, single choice. So dimensions of pressure is ml minus 1, T power minus 2. Or you can remember the dimension formula for pressure or force. Force dimension you can keep in mind, ml T power minus 2. Okay, and area is L square, so we will get pressure dimension is ml minus 1, T power minus 2. Okay, now second question, the dimensional formula of torque is, it means they are asking the dimensional formula of torque they are asking, and this question was asked in CBSE PMT 1989. So what is torque? Torque, we know that torque is equal to force into perpendicular distance. Force into perpendicular distance. Okay, and what is the formula for the force? You can keep in mind mass into acceleration, that is ml T power minus 2. And distance formula, distance dimension is L. So what you will get? The dimensions of torque is equal to m L square, ml square T power minus 2, ml square T power minus 2. Okay, this is also a very simple question. All these are based on the dimensional analysis. So ml square T power minus 2, which option is correct? ml square T power minus 2. Option A is correct. Okay, so you can write down, pause the video and write down. Now we will see the question number 3. Okay, what is the next question? Question number 3, the dimensions of universal gravitational constant, and this was asked in CBSE 92 and 2004. 2 times it has been asked. Now what is gravitational constant? We know the gravitational force. Okay, we know that gravitational force F is equal to G m1 m2 upon r square. This you know that. Okay, so from this what we will get? Capital G, which is universal gravitational constant, is equal to F r square upon m1 into m2. So the dimensions of gravitational constant will be equal to Fr square, dimensions of Fr square upon m1 m2. And I already told that, remember the dimensional formula for force ml T power minus 2, that is mass into acceleration. Then dimensions of r square means L square. r is the distance between the two masses, and dimensions of mass is m, so m into m square. What you will get? M power minus 1, m power minus 1, then L square, and L is L cube, and t power minus 2, m minus 1, L cube, t power minus 2. Which option is correct? Option A is correct. Okay, so this is also very simple, and it has been asked 2 times. Okay, 1992 and 2004. Then the fourth question, the dimensions of impulse are equal to. So here they have not given the dimensions, but they have given the other physical quantities. So you should know what is impulse. Okay, impulse is nothing but force into that small time interval. Okay, and force dimension is ml t power minus 2, and dimensions of change in time is t. So what you will get? 1 t will get cancelled, ml t power minus 1, ml t power minus 1. So we are getting ml t power minus 1. Now we'll check pressure. Pressure is dimensions of pressure. Dimensions of pressure is equal to dimensions of force upon dimensions of area. Dimensions of force is ml t power minus 2. Dimensions of area is L square. So what you will get? Okay, dimensions of force you should keep in mind, mass into acceleration, ml t power minus 2. Area dimension is L square. So what you will get? M L power minus 1, m L power minus 1, and t power minus 2. So this is not same. Okay, now we'll check for linear momentum. Okay, linear momentum dimension, and we know that linear momentum is equal to mass into velocity. From 9th class you are studying this. Dimensions of momentum will be equal to dimensions of mass into dimensions of velocity. Dimensions of mass is m, dimensions of velocity is L t power minus 1. So ml t power minus 1. Now we are getting this impulse is equal to linear dimensions of impulse and linear momentum are same. So which option is correct? Option B is correct. Okay, actually the dimensions are not these ml t. Okay, the dimensions are the powers. Okay, dimensions are the powers to which these fundamental quantities are raised. Okay, so if someone is asking what is the dimension of impulse, so you have to say that the dimension of impulse is 1 in mass, 1 in length, and minus 1 in time. Okay, so that dimensions are the powers to which these fundamental quantities are raised. So this is also a very simple question. Force dimensions I will tell you. Okay, the answer we got, but I will tell you for the force. Force is nothing but mass into acceleration again. Okay, that is ml t power minus 2. Keep in mind this, always you have to keep in mind angular momentum. And what is angular momentum? mvr. So the dimensions of angular momentum will be equal to dimensions of m into v into r. M is mass, velocity is L t power minus 1, r is L. Okay, so the dimensions of angular momentum will be equal to ml square t power minus 1, ml square t power minus 1. Okay, so the dimensions of impulse and linear momentum will be same. So option B is correct. Okay, so please pause the video and write down. Okay, before watching the solution, you try yourself. Okay, in this way you will get confidence. Okay, in this way you will get confidence and you can score full marks in physics. Okay, so we will try to solve all the previous questions from these examination. Okay, write it down. Let us see the next question. Question number 5. Okay, according to Newton, the viscous force acting between liquid layers of area A and velocity gradient delta v upon delta x is given by F is equal to minus eta A delta v by delta x, where eta is the constant called coefficient of viscosity. The dimensional formula of eta. Okay, they are asking the dimensional formula of eta, and this question was asked in CBSE PMT 1990. Okay, this is also very simple. From the formula they have given, force is equal to minus eta A delta V upon delta x. Okay, delta V upon delta x is velocity gradient, A is the area and F is the force. So you can write down from this equation eta is equal to F into delta x upon A will come in the denominator and delta V also come in the denominator and minus sign. So dimensional formula of eta will be equal to dimensional formula of force into dimensional formula of delta x upon dimensional formula of area and dimensional formula of delta V. So dimensional formula of force is mLT per minus 2 and dimensional formula of delta x is nothing but distance. Okay, distance formula is L and dimensional formula of A is L square and dimensional formula of delta V, that is change in velocity, LT per minus 1, okay, meter per second. If you know the units also, then you can easily find the dimensions, LT per minus 1. So what you will get, L square in the denominator will get cancelled by numerator, okay, and 1 L will in the numerator, okay. So what is left, M is left, then this L square will get cancelled by these two L's, L power minus 1, L power minus 1, and T, 1 T will get cancelled, so T power minus 1. So the dimensional formula of eta, that is the coefficient of viscosity, we are getting ml minus 1 T power minus 1. Okay, they have asked many times in the other exam also, so you can keep in mind this ml minus 1 T power minus 1. So option D is correct. Okay, so write down, if you know the, okay, instead of formula, if you remember the units also, okay, units, then from units also you can easily find the dimensional formula. Okay, please write it down, pause the video and write it down. Now let us proceed for the next question, question number 6. Okay, it looks very big question and very difficult question, but this is the easiest one. Okay, just read it. Turpentine oil is flowing through a tube of length L and radius R. The pressure difference between the two ends of the tube is P. The viscosity of oil is given by eta is equal to P into R square minus X square upon 4VL, where V is the velocity of the oil at a distance X from the axis of tube. The dimensions of eta are, okay, this is a similar question, okay, as question number 5. Directly we can put, okay, I told you to remember the dimensions of eta, directly you can write down, no need to solve it at all. ml minus 1 T power minus 1. Suppose if you don't remember, then you can solve. This was asked in CBSE PMT 1993. Okay, let us try to solve this. Okay, eta is equal to P R square minus X square. Okay, this is one term. Okay, this complete one term. Okay, 4VL. So the dimensions of eta will be equal to dimensions of P into dimensions of this term R square minus X square upon dimensions of V and L. Dimensions of pressure will be equal to force upon area. Okay, dimensions of pressure is dimensions of force upon area. R square is L square, you can write down L square. Then V dimension is LT power minus 1, L dimension is L. Okay, let us write down dimensions of force. Dimensions of force, you have to keep in mind mLT power minus 2, that is mass into acceleration, then L square upon dimensions of area is L square and L into L square T power minus 1. Now 1 L square will get cancelled, 1 T will get cancelled, L becomes minus 1. Okay, so what is the dimensions left? M, L is 1 minus 2, that is minus 1. So L power is minus 1 and T power is 1 T is get cancelled. So T power is minus 1. ML minus 1 T power minus 1. So what is the dimensions coming? ML minus 1 T power minus 1. So option D is correct. Okay, this is also very simple question. You can keep in mind the dimensions of eta. Eta is the coefficient of viscosity, always ml minus 1 T power minus 1. Okay, pause the video and write it down. Let us proceed for the next question, question number 7. Okay, the dimensional formula of angular momentum is, okay, dimensional formula of angular momentum we have to find here. We should know that angular momentum is equal to mvr, okay, mass, velocity and radius, or you can say perpendicular distance from the axis. So the dimensional formula of angular momentum L will be equal to dimensional formula of m into v into r. M is mass, so it is capital M. For velocity it is L t power minus 1, and for radius it is L. So it becomes ml square t power minus 1, t power minus 1. So the dimensions of angular momentum is coming as ml square t power minus 1. So option D is correct here. Okay, this was asked in CBSE PMT 1988. Okay. Then dimensions of Planck's constant equal to that of, so first we should know what is Planck's constant. E energy is equal to, this formula you should keep in mind, h into nu. Okay, E is the energy of a photon. Okay, energy of a photon is given by E is equal to h into nu. Nu is the frequency. Therefore h is equal to E upon nu. Okay, so the dimensions of h will be equal to dimensions of E upon dimensions of frequency. E dimension is ml square t power minus 2. Okay, that is force into distance. Force dimension is ml t power minus 2 into L ml square t power minus 2, and frequency dimension is t power minus 1, t power minus 1. So how much it is coming? M L square, and 1t will get cancelled, so t power minus 1, t power minus 1 is coming. Okay, this is the Planck's constant dimensions. Then energy dimensions, we first write down all the dimensions, then we will get to know the dimensions of Planck constant is equal to that of energy. Okay, the energy is nothing but force into displacement, that is ml square t power minus 2. Then momentum, what is momentum equal to? Momentum is mass into velocity, so dimensions of momentum will be equal to dimensions of mass into dimensions of velocity. Dimension of mass m, dimension of velocity is t power minus 1, ml t power minus 1 not coming. So angular momentum, we'll see angular momentum we have already calculated in the previous question. You can see from here the dimensions of angular momentum is ml square t power minus 1, ml square t power minus 1, and power, now we got it. Okay, h ml square t power minus 1, no need to calculate for power. Okay, so the dimensions of Planck's constant is ml square t power minus 1, and dimensions of angular momentum is also ml square t power minus 1. So you can write down option C is correct. Okay, this was asked in CBSE PMT 2001. These are also very simple questions. Okay, for these type of questions you have to learn all the formulas, okay, of which are given in the chapter 1, or units and measurement. There are lots of physical quantities are given, and their formulas are given, and their units are given, and how to find the dimensional formula also given. So you can learn that table, so easily you can solve this. We should not waste time in solving this, so directly we can solve it. Okay, so please pause the video and write it down. Okay, now let us proceed for the next question, which is question number 9. Okay, the ratio of dimensions of Planck's constant and that of moment of inertia is the dimensions of. Okay, they have given the other physical quantities: time, frequency, angular momentum, and velocity. So Planck's constant, we know that E is equal to h into nu. So from this we get h is equal to E upon nu. Dimensions we can find of h is equal to dimensions of energy upon dimensions of frequency. Dimensions of energy is ml square t power minus 2, and dimensions of frequency is t power minus 1. Okay, so what we get? 1t will get cancelled, m l square and t power minus 1. Okay, we get this. Then what is the dimension of moment of inertia? And moment of inertia is I is equal to mr square. Okay, this we will study in rotational motion, mr square. So dimensions of moment of inertia I is equal to dimensions of m into L square. What are they asking? They are asking the ratio. Okay, so you can easily find the ratio of dimensions of h upon dimensions of I. Dimensions of h is m L square t power minus 1, and dimensions of moment of inertia is m L square. So what we get? Okay, ml square will get cancelled, m will get cancelled, L square get cancelled. What is left? T power minus 1. And we know that t power minus 1 is nothing but the dimension of frequency. So this is the dimension of frequency. Okay, so option B is correct. Okay, this was asked in CBSE PMT. Okay, CBSE PMT 2005. CBSE PMT 2005. Okay, then next question, dimensions of R in the electrical circuit. R is resistance. Okay, R is resistance, and we know that from Ohm's law, V is equal to R into I. Therefore R is equal to V upon I. I is the current, V is the voltage or potential difference, and V, we know that it is work done per unit charge. Work done per unit charge. Okay, and I is equal to Q upon T. Therefore Q will be equal to I into T. Okay, I into T. That is, the dimensions of Q will be equal to dimensions of I and time. So we can write down W upon I into I. Okay, I square, it becomes I square in T. So we can find the dimensions of R will be equal to dimensions of W is work done upon dimensions of I square T. Work done is nothing but it is the energy. Okay, so dimensions of energy is force into distance, ml square t power minus 2. Okay, ml square t power minus 2 is the dimension of energy. Work done is nothing but the energy. I square is I square, I square is I square. Okay, because current, electric current is the fundamental quantity, so the dimension is I, and for time is T. So what is left? M and L square. Then T, if we will take in the numerator, it becomes minus 3. Minus 3 here. So T power minus 3 and I power minus 2. I power minus 2. So the dimensions of resistance is equal to ml square T power minus 3. So which option is correct? Option C is correct. Okay, you can match ml square T power minus 3 I power minus 2. So option C is correct. Okay, and this was asked in CBSE PMT 2007. Okay, so these all are very easy questions if you remember the formula and or the units of all the physical quantities. Okay, so please pause the video and write it down. Okay, let us proceed. Question number 11. Okay, dimensions of self-inductance. We have to find the dimensions of self-inductance. What is self-inductance is equal to, okay, self-inductance, this formula you should know. Self-inductance is equal to EMF upon current per unit time. Okay, and what is EMF? EMF, it is nothing but potential, that is work done upon per unit charge. Okay, and this T will go in the numerator, and current, for current you can write down I, and Q is equal to, okay, we know that I is equal to Q upon T. Therefore Q is equal to I into T. Okay, in 10th class in current electricity also you have studied I into T. You can write down for Q, and work done is ml square T power minus 2. That is the dimensions of energy. Work done is nothing but energy, ml square T power minus 2 into T upon Q dimension. You can write down I into T, and dimensions of current is I. So you can check. Okay, sorry for the disturbance. Okay, now ml square t power minus 2, this t will get cancelled. Okay, and what is left? m l square. Okay, m l square t power minus 2, t power minus 2 is left, and I square in the numerator it becomes I power minus 2. Okay, m l square t power minus 2, I power minus 2. Okay, so which option is correct? ml square t power minus 2 and ml square. Okay, we'll check. This one, C option is correct. Okay, ml square t power minus 2, a power minus 2. Instead of I, you can write down the A for ampere. Okay, for current you can write down A also. Okay, so ml square t power minus 2, a power minus 2. Option C is correct. Okay, this option is correct, and this was asked in CBSE PMT 1989. Okay, now question number 12. If C and R denotes capacitance and resistance, the dimensional formula of CR they are asking. Okay, CR, we know that C is equal to Q upon V, and VR we know that V upon I. So this V will get cancelled, and dimensions of Q is equal to I into T upon I. Okay, so what is left? T. So the dimensions of CR will be equal to T, that is m0 L0 t power 1. Okay, so this is also very simple question. This was asked in CBSE PMT 1989. Okay, so in the next second part we will do the other questions. You can write down and pause the video. You can share the students who are preparing for the NEET 2023. Okay, NEET 2023, because we will solve all the previous year's questions in this series. Okay, thank you.